Hello everyone, I'm Frank, and welcome to episode 41 of Learn How to Sudoku, where we take very easy variant Sudoku puzzles and we break them down into detail so that you can learn how to Sudoku. Today's very easy puzzle is called Cage Quivers by Full Deck and Missing a Few Cards. And here are the rules. In a short, sweet sentence, it's standard Sudoku rules, arrows, and cages. Now, let's explain each of these. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Arrows. Digits along the shaft of an arrow sum to the value in the attached circle. So basically, these two digits would have to add up to what this digit is. So for example, this could be 3 and 5, and this would be 8 then, because then these two digits add up to what this digit is, right? So that's how arrows work. Cages. Digits in cages cannot repeat and must sum to the value shown in the upper left corner of the cage. So that would mean, again, you can't have repeats in cages, but you can't have repeats in normal Sudoku rules. So, but for example, using this arrow in this cage, these four digits must add up to 22. Well, we already have a 3, 5, and 8 here, by just as an example. Therefore, the last digit must be 22 minus 3, 5, and 8, which would have to be 6. So therefore, if this were 3, 5, and 8, this would have to be a 6 to make this whole cage add up to 22. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the thing that sticks out to me immediately is the 10 cages. If you ever have four digits, unique digits, adding up to 10, you know they have to be specifically 1, 2, 3, and 4, because that's the only possible combination of unique digits that can ever add up to 10 in normal Sudoku. So this must be some combination of 1, 2, 3, 4, and two of those digits must add up to another one. Well, what are the possibilities? That means this could be 3 or 4, right? Because it could be 1, 2 added together or 1, 3 added together. So if this is 4, this becomes 1, 3, and this must be 2. If this is 3, this is 1, 2, and this must be 4. So each of these 4 cages are like that, right? So this is 3, 4, 1, 2, 3, 2, 4, 3, 4, 1, 2, 3, and 2, 4. And this is also 3, 4 here, 1, 2, 3, and 2 or 4 here. Well, interestingly enough, we have a 2, 4, 2, 4 pair in, should we go that way or should we go a different route? I'm not sure. Let's go a different route. Let's handle the 26 cages that we have, right? We have 4 of those also. Now, this digit has to be the sum of these two digits. So, what is the possible digit that can be there that could still add up to 26? Well, if we try 8 or lower, this would be 8, and this would sum up to what 8 is, right? Which would be, so this would be 8, this would be 8. These 3 then would sum up to 16 if this were an 8. But the problem is we have one digit, which would then have to be 26 minus 16, which is 10, which is not a digit. So this can never be 8 or lower, right? We tried the highest one out of 8 in below, and it doesn't work. So therefore, this must be then a 9. And similarly, all the other 26s must have a 9 in each of these arrow circles, right? So this must be 9, this must be 9. Now, because of that, we know that these 3 digits add up to 9 times 2, right? Because whatever is on the arrow sums up to what's in the circle. So therefore, this has to be 9 times 2, which is 18. And 26 minus 18 is 8. So therefore, in all the remaining cage cells that in the cage, that's not on the arrow or in the circle, it must be an 8. So this must be an 8, this must be an 8, this must be an 8, and this must be an 8 because of that. What else should we attack? Well, let's attack this 14 cage. This cannot be 1, 2, 3, 4, right? Because we have a 1, 2, 3, 4 quadruple in column 9, which eliminates 1, 2, 3, and 4 from the rest of the column. So this is at least a 5. So if this is 5, this would add up to, these two would add up to 2 times 5, because again, remember, the digits on the arrows sum to the same as the digit in the circle. So again, if this were a 5, this would be 2 times 5, so therefore we know this would then be a 4, because 14 minus 10 is 4. So this would be 4 then, if this is a 5. So if this were 5, this would be 4. This could no longer be 1, 4 to add up to 5. Therefore, they would be 2 and 3. Similarly, okay, if this were a 6, this would add up to 12, and this would have to be a 2. Well, we have 2 digits adding up to a 6, but it cannot be 2, so this would have to be specifically 1, 5 to add up to 6, right? Either way, there has to be a 5 in one of those 3 cells. And in addition, if this were 5, this would have to be 2, 3. This would be 4. Well, the 2 and 3 could no longer be here, so this would have to be 1 in that situation. If this were 6, this would have to be 2, and this would have to be 1, 5. So this could only be 3 in that situation. Let's see, what else do we have? So that's what I like targeting that one because that looked like it limited things a decent amount, which it kind of did. So we know then we cannot have 1, 2, and 3 or 5 in the rest of row 6 because they're either in this cage or it's here, right? 2 has to be in this cage no matter what. And 1 and 3 could be either here or here. And 5 obviously has to be one of these 3 cells. So the rest of these digits must be 7, 9, 4, or 6, right? Cannot be 1, 2, 3, and it cannot be 5. And 8 is already eliminated. So this is 4, 6, 7, 9. Maybe let's attack the 22 cage now. The rest of this cage cannot contain a 2 or 4. What are the possibilities for this circle? Well, let's try 6 or below. If we try 6 in this circle or below, the maximum value this can have would be 6 times 2, which is 12. Well, we would have then one digit, which, and this can't be a 4, because we have a 2, 4, 2, 4 pair in column 5 also. But if we tried this as a 6, the problem is that, again, these 3 digits in this cage must add up to 12 at most if it's a 6 or below. And therefore, this cell would have to add up to, would have to be a 10, which is not a normal Sudoku digit. So 6 and below does not work. If we tried 7 and below, that wouldn't work either, because 7 times 2 is 14. Oh, actually, that does work. Never mind. So this could be 7 or 9. Okay, let's try 9. If this is 9, that means these 3 digits would add up to, these 3 cells would add up to 18, right? Because these 2 must add up to 9 also. So it's 2 times 9. 22 minus 18 is 4, which would be which would have to be in this cell, but it can't be 4 because of this 2-4 pair in row 5 and this 2-4 pair in column 5. So 9 is removed as a possibility. And it can't be 8 because of that 8, so it must actually be 7 here. Now this 7, again, makes this essentially... Actually, we kind of already knew what this had to be. This had to be 8 because this can't be 8, this can't be 8 here, and this can't be 8, and this can't be 8. So in that box, where can the 8 be? It has to actually be here, right? This 7 must have 2 digits adding up to it, and it cannot be 2, 5 because the 2 is eliminated by this 2, 4, 2, 4 pair, and it can't be 3, 4 because the 4 is eliminated by that same 2, 4 pair. Therefore, this must be specifically 1 and 6. Now we have a 1, 6, 1, 6 pair in this box, which eliminates 1 from the rest of the box. Because 1 and 6, again, and it eliminates 6 from the rest of the box also, actually. So this can no longer be 1, because, again, if you tried to make this 1, that would eliminate the 1 as a possibility for either of these cells, and then they would both have to be 6. That's the reason why you can't have, once you have a pair of numbers which have to be 2 specific digits, you can eliminate all the rest of, you can eliminate those digits in the rest of the box or rest of the column or the rest of the row, depending on where it is. So this can't be 1, therefore this must be 3. This can't be 6. Now this can't be 3 anymore, so this thing that added up 2, 3 to 2, 3, which added up to 5, is no longer possible. So this can't be 2 and 3. This has to then be 1 and 5, which forces this to be 6 and this to be 2. So 6 can no longer be any of these cells. 7 can't be any of these cells, so this must be 9 because of this 7. This has to be 4. This can't be 4 or 9, so this is 7. Well, this is 3. This can't be 3 anymore, so this must be 4. And these 2 digits must add up to 4. So this is a 1, and this is a 2. Which forces this to be 4, which means this can't be 4, so this is 3. These can't be 3 anymore. And this can't be a 1, because again, of the 1, 5 pair in this box. Which eliminates 1 from the rest of the box, which makes that a 2, which makes that a 1. Okay, what else do we need then? Where should we attack next? This row, the remaining digits have to be 3, 5, and 9. Well, 5 cannot be here. Where can 5 be in the rest of row 5? It has to be here. So this is a 5, and this is a 3, 9 pair. Well, now we have a 3, 9 pair in this box, and we have a 1, 5 pair in this box, which eliminates those digits from the rest of the box. Therefore, this can only be now a 7. The remaining digits here are 4, 5, and 9, right? Well, this can't be... Well, this could be 9, actually. This can't be 4. Oh. This can't be 4, because if this... Okay, this can't be 9. This can't be 4 or 9, so this must be a 5, which makes that a 4 and makes that actually a 9. So that makes that very simple. Right, this had to be 4, 5, 9 because of the 1, 6 pair in the box and the other cells being 2, 3, 8, and 7. So this has to be 9. These 2 digits add up to 9, and it cannot be 1, 8 because of the 8. It cannot be 2, 7 because of the 7. It can't be 4, 5, so this must be specifically 3 and 6, which forces this to be a 1. This can no longer be 1, but where is the 1 in this cage, right? We need a 1 in that cage, and it can only be here. So this is a 1. Let's see, what else do we have? Where do we want to tackle next? This cannot contain a 1 in this cage. So what are the possibilities now? It could be 2, 3, 4, 7, adding up to 16. or 2, 3, 5, 6. And you can't have... Okay, so it's 2, 3, 4, 7, which would make this essentially a 7 with 3, 4 here and this 2. Or it's 2, 3, 5, and 6, which would force this to be 5 and this 2, 3, and this 6. And I think those are the only possibilities without a 1, right? 2, 3, 4, 7, which is the minimum amount with the highest digit possible. And then you swap the highest digit down 1, which would be a 6, which would mean that 4 can go up. But you can't have any other ones there, right? So we know then this has to be 2 and 3, right? Because you have to have 2 and 3 in this set of 4 digits adding up to 16 without a 1. Therefore, the rest of the row cannot contain 2 or 3. And it can't contain 1. So therefore, this has to be 4, 5, 6, 7, and it cannot be 8. Well, correspondingly here, what do you have? This could be, to add up to 9, this would have to be 2, 3, 4, or 5. Well, this can't be 3, so this can't be 6. Interesting. This can't be 1 because of this 1, so therefore this must be 5, which makes this a 1. This can't be 9 because of this 9, so this must be 3, which makes that a 9. Therefore, this can't be 3, so this must be 4, which makes that a 3 to add up to 4 with 1, and therefore this is a 2, which makes this 4, which means this is 3, and this can't be 3. Well, this can't be 4, 5 anymore, so this must specifically be 2 and 7. So this is 2, this is 7, which makes that a 5. Therefore, this has to be 2 and 3 to add up to 5, which forces this to be a 6. This 6 means this can't be 6, so this is a 1. This 3 means this can't be 3, so this is a 2, which makes that a 3. This 2 means this can't be 2, so this is a 1, which makes that a 2. These 1s mean this can't be 1, so this is a 6. This 3 can't be a 3, so this is a 6. That makes that a 3. This cannot be 1, 8 because of the 8. It can't be 2, 7 because of this 2 here, and it can't be 3, 6 because of that 3, so it must be 4 and 5. This can't be 4, though, so this is 5, and this is 4. The remaining digits in this cell are 2 and 7, so therefore this is 2, 7. Remaining digits here have to be 7 and 8. So this is 7, 8, 7, 8. We have a 7, 8, 7, 8 pair now in column 1, which eliminates 7 and 8 from the rest of the column. Therefore, this must be 6. The remaining digits here are 3, 5, and 8. This can't be 8. This can't be 3. Remaining digits here are 1, 5, and 9. This can't be 1 or 9, so this is 5. This can't be 5 or 9, so this is 1, which forces this to be 9. Remaining digits in column 5. Yeah, I'm just going down the list, essentially. Well, let's go tackle this one. This cannot be 1, 8 because of the 8 here. It also cannot be 2, 7, and the reason why is if this were 2, 7, that would eliminate all... Well, first of all, this can't be... This 2, 7 means one of these can't be 2 or 7, so therefore that can't be 2 or 7. But also, if you try to make this 2 or 7, that would eliminate all possibilities for this cell here, right? So therefore, this can't be 2, 7. It can't be 4, 5 because of the 4. So the only remaining digits now must be 3 and 6. And this can't be 3 because of this 3, so this must be 6, which makes this 3. This can't be 3, so this is 5, which makes that 8. This 5 and 8 means this can't be 5 or 8, so this is 3. The remaining digits here now in row 8 has to be 2 or 7, but this can't be 2 because of that 2. So this is 7, which makes this 2, which makes that 7. And now we're probably just going down to and doing normal Sudoku. So the only digit remaining in column 8 is a 5. This is only a 7. The remaining digits here are 2 and 8, but this can't be 2, so this is 8, which makes that a 2. The remaining digit here has to be a 5. The remaining digits here are 4, 6, and 8. Well, this can't be 4 or 8, so this must be 6. This can't be 4 or 6, so this must be 8, which makes that a 4. This 8 means this can't be 8, so this is 7. This is 8. This must be then 6. The remaining digits here are 1 and 7, but this can't be 1, so this is 7, which makes that 1. This must be a 9. This must be a 6, and this must be 4. And that's the solution. Yeah, pretty straightforward. How you tackle these cages. That's why I've done killer cage Sudoku a lot in the past. It's basically I started doing variant Sudokus during the pandemic, and I've done a lot of killer Sudokus, so I'm able to identify patterns very quickly. So I was able to find the 10s there, and then with the arrows, I was able to target the 26s next. And then I knew that the 14 was going to be very limited because of how the digits could be, right? Anyways, I hope that made sense about how I was tackling these solving the Sudoku. It's sometimes tricky, but it's once you start getting into variant Sudokus, you start seeing a lot of patterns that are very similar, which really restrict things a lot. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.